Welcome students. How are you all? Hopefully all are good and doing well about your studies also. So in support of that only, we are going to start our second unit today, and from this class onwards we will study about the concepts involved in second unit. So the name of second unit of our syllabus is current, electricity, and here the first chapter which we are going to study is electric current and resistance. While we are dealing with electric current, we all know that it is a factor which we require in our daily life and is utilized in working of many appliances surrounding us. बहुत सारे ऐसे devices हैं which are there in our daily routine जिसको हम use करते हैं इस factor electric current की मदद से. So here in this unit, in this chapter, we are going to study about how this current is produced, what are the factors responsible for it, what are the factors associated with it, and we will study them one by one. So let's start our first chapter here, electric current and resistance. And before we proceed in this unit, let's understand the meaning of our unit, which is known as current, electricity. It is also known as, another term here is electrodynamics. In the previous unit, the name is electrostatics, and over there we have studied about the concept of electrostatics. Electro, which dealt with charges, and static, it was termed for rest. So over there we have discussed many factors, many quantities, many relations, derivations which were related to charges at rest. So now another branch or one step ahead, here we are going to discuss about the charges, same charges, but this time they will be in motion. So here this meaning electrodynamics termed for same condition, where electro is termed for charges or electrons, dynamic is used for motion. You must have learned about the concept of hydrostatics and hydrodynamics in the previous class, in 11th class, in properties of bulk matter. There was two chapters distinctly which were discussing about hydrostatics, where fluids were discussed at the condition of rest. Then hydrodynamics, fluids were discussed for the condition of motion. So in similar way, here also we have to discuss about electrodynamics also, after which we will come to know about the complete concept of electric charges. Electrostatics we have completed. Now we are going to start with electrodynamics. Electricity again for electric charges, or this term current, here the word current is utilized especially for the motion. In most of the cases you must have heard about water current. So whenever this phrase water current is used, it is associated with the case where the water is flowing, especially for river water. So water current word denotes the flow or motion. So here current, electricity also deal with charges in motion. So simple definition we can define like this: it is branch of physics again in which we study about charges in motion. So as we all know that most of the term in physics define themselves if we consider them in multiple parts. So here this term current, electricity, or electrodynamics, it is defining its definition on its own, the branch of physics in which we study about charges in motion. Obviously this charge, in most of the cases it will be in the form of electrons, but it is not always. It may be in the form of positive ions also, or positive particles also. So charges in motion will be considered in this entire unit. And now to proceed with this factor, the flow of charges in a definite direction constitute electric current. This type of definition you must know from 10th class also. Over there few basic concepts were there, and from that we simply define that electric current is defined as rate of flow of electrons or rate of flow of charges. So rate means the factor for which it is used, that will be divided by time. Rate means divided by time, and for what factor it is used, it is rate of flow of charge. So what amount of charge is flowing, in what time it is flowing, taking the ratio of the two will give us the current directly. but that was the simple concept which we have studied in the junior classes. Here we should know about the basics of electric current. So to learn about that, we have another term which is known as current carriers, also known as charge carriers. Current carriers and charge carriers, these are those charge particles which again define them by their own name. Current carriers, the vectors which will carry the current. How? We will discuss it. Charge carriers, again the particles which will carry the charge, and then they will take it from one point to another. So that will depend on what type of medium we are dealing with, but in general we define this current carriers or charge carriers in the way that these are charge particles. These are those charge particles whose flow in a definite direction. This is very important. The flow should be in definite direction. Whose flow in definite direction constitutes electric current. So these are those particles, those charge particles, when they start flowing in a definite direction, they will form the electric current. So the important factor to produce electric current, these are the factors, current carriers or charge carriers. Now depending upon the type of medium, we have different types. So number one, for solid, which means conductors, or we can say metals, here we have charge carriers as free electrons. Here the meaning of free, you must know about this. Electrons which are present in the crystal lattice, but there are two types of electrons which are present in the crystal lattice. That means over there we have two types. One is of lower energy which are bounded within the atom, and another one of higher energy which are free to move from one point to another anywhere. This can be simply understood in the example of a school environment, where we generally used to observe two types of students over there. One which are bounded within their class under the effect of teachers, but some are more energetic, more powerful, which they think that they are, and they have tendency to move here and there in during the school time, during their class time also. Might be possible you have gone through like these particles in your school also. And similarly here we have two types of electrons. We are dealing here with the energetic electrons which have tendency to move from one point to another within the crystal lattice. But those students which we are comparing here with the free electrons, those energetic and special character students which have tendency to move here and there for bunking of the class, but they move from one point to another within the campus only. They are not able to move out of that campus. So similarly, free electrons are the energetic electrons which have tendency to move from one point to another within the crystal lattice, within the substance, but cannot leave the surface of that substance. So these are those free electrons, energetic electrons, and when they flow in definite direction, when they move in definite direction, they constitute electric current. Then another medium, after solid we have obviously liquid. Liquids means where we have electrolyte, we can say electrolyte. For electrolyte we have charge particles, charge carriers, current carriers in the form of positive as well as negative ions. Here both positive and negative in the form of ions are responsible for making electric current. Then third and the last, for gaseous medium, it is in the form of positive ions and again free electrons. Basically we consider gaseous medium as an insulator through which electric current cannot pass, but that is its general condition. Whenever any insulating medium like that gas is ionized, some extreme energy is given to that, and its atom from the neutral state loses the electrons and acquire positive charge. Then in the environment we will get positive ions, and free electrons, which are free due to the supply of extreme energy, and that causes two types of charges over there in the medium, and they, when they start flow in a definite direction, again they form electric current. So that is the condition of positive and negative ions. Very rare we will deal with the gaseous cases, liquids, very few cases we will discuss, but this is the main important part. For solids, for conductors or metals, we will deal with these free electrons, energetic electrons. So now the factor which will make electric current in the circuit, that we understood. Now how they will move in a definite direction. Like suppose this is a metal wire, and we know that in every metal wire electrons are in free state because of their higher energy, and due to that higher energy they have tendency to move here and there, like those bunking childs, those who used to bunk their classes. So they have tendency to move here and there randomly, and that is of no use, because they are moving here and there randomly, cancel each other's effect, involves with each other only, and start wasting their time. So similarly here, the electrons which are moving here and there randomly and cancelling each other's effect are of no great use, because they are not making any resultant current or net current, they are not making. So the factor which will cause the electric current to produce for making them in a definite direction, that we require here. And here the factor which will do this work is known as electromotive force. Electromotive force, in short, it is called EMF. E electro is used for electron or electric charges. Motive is used for motion. They should be in motion in a definite direction, and for this some force will be required. So to bring all the randomly moving charged particles in a definite direction, we need a source which will exert force on those particles and make them in a definite direction, and that will cause electric current after that. So for that we should apply this type of source in the circuit or in the medium in which we require electric current. And for that, here generally, first of all, let's define this. It is a source of energy which exerts force on charge carriers. It may be either free electrons or positive negative ions, or positive ions and free electrons, depending upon the type of medium. So on the charge carriers, the factor which will exert the source of energy which exerts force to make them flow in a definite direction, so that they can make electric current, that we require here. And that source which will do this work is known as electromotive force, in short EMF. Now if we consider the concept of unit of this factor, SI unit, how we will define it? Electromotive force. Force means whenever we are dealing with force, we know that the SI unit is Newton, but here it is not so. Newton is not the unit of this factor. So if we deal with the definition, it is the source of energy. Energy means joule. Again, joule is not the SI unit of this factor, because it is a broad term, electromotive force. Here in the case of electricity, we have, suppose we have a wire, this one, and it consists of number of atoms, from which it has number of atoms, and due to the excessive energy, the electrons from these atoms came out, and they are moving here and there randomly because they cancel each other's effect. So we can consider them as overall motion is zero. So we are considering them at rest. These are the positive ions which remain fixed in the crystal lattice, but we need these charged particles, these free electrons. These are free electrons. These free electrons need to move in a definite direction, then only they will make electric current. So the factor which can perform work in bringing charged particles from one point to another, this type of requirement is obtained from electrostatics over there, which we have discussed as electric potential. You must know from that. If you haven't gone through that video, you must go through the chapter electrostatics. Over there in the playlist you will get that, and from there we can easily understood that the electric potential is that factor which performs work in bringing a charged particle from maximum distance infinity to a point, and when we convert it in the form of electric potential difference, the factor will perform work in bringing the charge from one point to another. Here we need to bring these charged particles, free electrons, from one point to another, and for that we should apply some potential difference, and that can be obtained easily by connecting the wire with a cell. This is the symbol of key. Whenever this point is mentioned like this represents completion of the circuit, and these are two terminals of the cell. Positive end is connected with this, so it will make it positive. Negative end is connected with this, so it will make it negative. And we always know that whenever there is positive to negative effect, there is a term called electric field. Electric field will be developed across the wire, across the length of the wire, due to this source of potential difference V. And now what will the effect of this connection? This positive charge will start attracting electrons towards it. Similarly, this negative charge will also start repelling these electrons, and if we consider that no positive charges are there, easily these electrons will start moving from negative end to positive end of the conductor, and now all the free electrons are moving in a definite direction. They will form electric current in the circuit. So here the EMF is obtained from a cell. So in this unit, the EMF which we will need, that will be obtained from EMF of a cell only. So this term should be known. Moreover than electromotive force, the general term. So EMF is obtained in the form of potential difference. So here in this unit, the source of EMF will have unit volt. This we have already discussed in previous unit. So here EMF of a cell means the factor which will perform work in bringing charges from one point to another, or negative end to positive end with respect to electrons, and they start moving in a definite direction. We can relate this case of children also. The children needs to move from one point to another for many purposes, like to move out for a picnic only, to move out for watching a movie, or for shopping to the market, or to the school, even to the tuition points or study points. Wherever you want to go outside, you will need some source of energy, and that energy is not your physical energy. That energy will be the support of money also, and that you will get from your parents only. Whenever you feel to move out for these cases, you always look towards your parents, and they provide you the required amount, and after that only you are able to move out. Suppose, just imagine that your parents are not expending any amount of money over you for these conditions, then you will not be able to move out. Even if you will go out, it will be of no use. So easily we can relate it with the earning or salary of our parents also. That will work as the source of EMF for you. That energy, when applied over you, then you will be able to move from one point to another in respect of any requirement. So that is the source of EMF. In different cases, we have different sources of EMF. Here in case of electrical circuits, it is a cell or battery. So definition accordingly will produce the SI unit as volt. Here if we define this, so we can consider this ability will be obtained from the cell to the circuit or to the conductor, and in the form of maximum ability will be in the condition when this key is open, when the cell is having the maximum ability, like the entire amount which your parents are getting in the form of salary or business income, that amount is used or utilized for the entire family, for the entire circuit. Definitely the maximum amount will be consumed over children's, but the entire amount is utilized for the complete circuit. So that complete maximum value on the first date of month, we can say in case of salary, that maximum amount is treated as EMF. So here also we define it as maximum, and maximum is only when the cell is not used in the circuit, it is in open circuit when no current is drawn from it. So similarly in the same way we will define it. It is maximum value of potential difference across cell when no current is drawn from it. So till this factor we have understood the concept of charge carriers, general introduction, charge carriers, electromotive force, and how it is provided in electrical circuit. Hopefully you must have understood this, and after this now we can understood the concept how the electric current is produced in the circuit, and for that we require some space, so you can note it down by pausing it. So let's start the concept of electric current, and by the simple definition we are defining it here again, that it is the rate of flow of electrons or rate of flow of charged particles, or it may be in the form of charge carriers or current carriers as we have discussed earlier. But now here in the diagrammatic form also we will understand this. This is the conductor, the same diagram we have drawn here, and here these free electrons will start moving towards positive end of the conductor, that means towards positive terminal of the cell, and when they start moving in a definite direction, definitely there will be a current. So electric current we define it as rate of flow of charge. Rate means divided by time or time taken. Here what amount of charge flows upon time taken. So in general we can write the term as I is equals to charge upon time, charge divided by time, or this charge can be expressed like Ne. Q is equals to Ne. We have earlier discussed in electrostatics. This is principle of quantization, and Q I is equals to Ne by T can also be the formula. Also for short or instant case or the condition of limit, this current can be written as dq by dt also, or mostly we uses small charge, so small q dq by dt. This is the formula. From this formula we can write the unit, SI unit, as coulomb per second, also known as ampere denoted by A. If dimensional formula we require to express, it is again capital A, and that we have already used in making dimensions of charge also. For charge it is IT, so AT, A into capital T will be the dimension for charge from this formula only. Then the quantity here, this is scalar. Quantity is scalar. This quantity is scalar, but there is one controversial question with respect to this, and that is what? That we used to express the direction of current. It is always direction wise, it is starting from positive end of the positive terminal of the cell and start moving towards the negative terminal of the cell. So this direction we used to represent here, but still we consider it as scalar quantity. So why it is so? For that we are having a note, very important. Current has direction, but it is scalar. Why? Because it does not obey or does not follow laws of vector addition, like that, in which direction is very important. Like suppose if we consider a vector quantity, this force F1 is 5 Newton, F2 is 3 Newton, and here we need to produce total force F net. So that we represent from the angle between the two. What is the angle between the two? That will impact the final result. It may be lying from minimum value 5 minus 3, that means 2, to maximum value 5 plus 3, 8. This will be the result. Anywhere between 2 and 8, the answer, final answer would be, that will depend on the angle. But in the same way, if we have current here 5 ampere and here 3 ampere, and whatever is the angle, the final answer here, the current passing is 8 ampere only. If we have these two wires in the same direction, then also the answer is 8 ampere. If we have in opposite or perpendicular direction with respect to this wire, then also it is 8 ampere, because here the total is done on the concept of scalar. It is not on the basis of vector. So that's why we consider this current as a scalar quantity. But if it is scalar, so why we are representing here the direction? What is the need of that? So that is for our convention, so that we can understood how or in what direction, in what definite direction the charged particles or charged carriers are moving. For that we used to represent this direction of current. So here this current which we have shown here, this is called conventional current, which in general we used to represent. So this is in general the direction of current which we used to represent, that is conventional current, and it is always opposite to the flow of electrons. So another note, current has, or which current? It is conventional current. So conventional current has direction opposite to flow of electrons. The direction in which electrons are flowing, with respect to that, in opposite direction we used to represent the direction of current. Always suppose negative is going in this way, current will be in this way. If negative charge particle is going in this way, current will be in opposite direction. Negative up, so current down, negative down, current up, always in opposite direction. Because we used to prefer to give the concept on the basis of positive factors only. So suppose if we have, in place of electron, we have positive particles here, any imaginary positive particles, they will be flowing in same direction of the electric field, and that's why we have represented in same direction, the direction of conventional current. Another current which we call it as electronic current, this is because of flow of electrons and it is in the same direction of electrons, but that is not generally expressed or mentioned in the cases. So we are representing the direction of conventional current here, and now this is the time to express some types of electric current. If we deal with types of current, so we have basically two types, although we have many variations in the current, but in general we used to represent current in two types. Number one is direct current, and number two is alternating current. The difference between the two must be known by each who is studying this unit, current electricity. So here we are dealing with these two types only: alternating current AC, direct current denoted by, in short, DC. So for this we used to express that current with constant magnitude with time. So if we want to represent it direction wise graphically, so we represent it like this: current and time, and it has at time 0, or when the current starts, it has some specific value. It will not change its value at all. It will be a straight line parallel to the time axis, which represents this current is constant. It is not changing its value. And if we express its source, here generally cell or battery produces this type of current. Another current, alternating current, it is a special current whose magnitude changes continuously. Also, direction changes periodically. that current is called alternating current. If we used to represent it with graph, it is like this, time and current, and here it shows this type of variation. In detail we will discuss it in coming units, but here we will deal with DC in detail. So upper part is treated as positive, lower part is negative, and this is called one complete cycle denoted by for the time capital T, known as time period. Detail we will discuss in fourth unit, electromagnetic induction and alternating current. Over there we will discuss this type of current in detail, but we have to compare these two with each other. So here direct current, the current whose magnitude remains constant with the time, and one more factor we can say, direction never changes, or direction also remain same. Here magnitude is changing continuously it is starting from 0 going to maximum, then coming back to 0, then changing its direction, going back to maximum again on another side, and then coming back to 0. This is one complete cycle. This cycle repeats itself again and again continuously and produces certain frequency also. So that frequency will be having certain value, means it will not be 0. Here if we consider the value of frequency, it is always 0. So source will be AC generator mostly, the supply which we have in our domestic circuit, AC mains, that also gives this type of current. So this is the two particular types of electric current. Here we will deal in detail with direct current only. Later on we will discuss about this. So now let's discuss some 2-3 questions on the basis of this concept. First you can note down by pausing the video. So these are few questions related to the topic which we have discussed here, and here the first question is, how many electrons pass through a lamp in 2 minutes if current is 300 milliampere? I will suggest that you will pause this video here and try to these questions here for some moment, and after that you just follow through the solutions. So if you have tried these questions, let's discuss. Let's start the solution of question number 1. Here question number 1 is, how many electrons pass through a lamp in 2 minutes if current is 300 milliampere? So here if we consider the given factors, the value is for time as 2 minutes, which can be written as 2 into 60 in seconds. Then current is given as 300 milliampere, which can be considered as 300 into 10 to the power minus 3 ampere, and we have to find the number of electrons. So definitely in this we need the value of charge of electron also, which is known as 1.6 into 10 to the power minus 19 coulomb, and this we know from our unit electrostatics. So we know that the formula for current is charge upon time, which can be expressed as NE upon T also, and from this the cross multiplication will give the value of L, that is I into T divided by E. So here I is 300 milliampere. So I 300 milliampere means 300 into 10 to the power minus 3. Time is 2 into 60 divided by E, that is 1.6 into 10 to the power minus 90. So 1, 2 and 3 0 can be balanced by 10 to the power minus 3. Then 6 into 2, 12, or we can do like this, adjust this decimal, 10 we will have in numerator, then this 2 will give 8, then this 3 will give 4, and 3 into 3 9, so it will give 9 by 4 into 10 to the power minus 19 becomes plus 19 and 1, 10 to the power 20, or if we convert it, so it will be 9 by 4 will be 2.25 into 10 to the power 20, or we know that number of electrons is not in decimal, so 225 into 10 to the power 18 electrons will be the answer. So this would be the answer for first question, and now let's do the second one. It is giving that an electron moves in a circle of radius 0.15 meter with a constant speed of 3.6 into 10 to the power 6 meter per second. So what electric current does this corresponds to? If we consider here the given factor will be radius 0.15 meter, speed 3.6 into 10 to the power 6 meter per second, and here we need to find the value of current. So here this is the situation of circle in which electron is moving in, suppose clockwise direction, so current will be anti-clockwise for radius r. So here the formula for current is charge upon time. For charge we have E, and for time we have distance for one round 2 pi r upon speed v. This is from the relation time is equals to distance upon speed. So this formula will be written like this, EV by 2 pi r, and substituting the value again you will get your answer 1.6 10 to the power minus 19, V 3.6 into 10 to the power 6, then 2 into 22 by 7, and R is 0.15. So adjusting the decimal, 2 decimal places, so 2 decimal places will be adjusted, this 0 will be removed, and this becomes 15 now, and then adjusting it is 8 to 11 times, so it becomes 18, then 3 5 times, 3 6, and now this 7 will be in multiplication with 6, 7 6 42, then 11 and 5 and 10 to the power minus 19 and 10 to the power minus 19 and 10 to the power 6, it will become 10 to the power minus 13. This is 10 to the power minus 13. Then 10 to the power 6 is solved, 36 is solved, it is 6 into 7 6, and one more factor is left, that is 8. So it is 7 6 42 into 8, one more 8 is also there, and now adjusting the relation we will get 7 11 8 to 16, 4 8 32, 33, 3 3 6, 10 to the power minus 3 minus 13, and 11 and 5 also. So 11 3, 30 times 60, 11 5 approximately 6 5 6 times 30, approximately 6.1 into 10 to the power minus 13 ampere. This would be the answer for this second question. So now for noting down it, you can pause the video. So now the last question, and here in this question it is given that if charge flowing in a wire is this, Q is equals to AT square plus BT plus C, which means here charge is variable with time. So differentiation formula we will use here. Then we have to find the dimension of ABC. ABC are constants, T is time, and if values of ABC is given as 3, 5 and 2 in SI system, find the current at T equals to 3 seconds. So given charge is AT square plus BT plus C, and values of A, B and C are given as 352, and we have to find at T equal to 3 seconds current is to be determined. Also dimensions of A, B, C we have to find. So first of all, here we will use the concept of principle of homogeneity, which we have discussed in 11th class also, according to which the factors which are in addition, they must have same dimension, and that will be equivalent to the factor to which they are equal. So here, according to principle of homogeneity, if you are not getting this name of the principle, no need to mention it, you can just write here dimension of C. Dimension of C will be directly equal to dimension of Q, and that is 80. Then dimension of BT, this is again dimension of Q, or if we remove this T from here, it will be in denominator. For charge it is 80, for time it is T only, and hence it will be A, which means it is representing the current ampere. Then dimension of AT square, this is equals to dimension of Q again. Adjusting the value of this T square, we will have Q by T square, and therefore it is AT divided by T2. So 1T will be balanced, and therefore it will give 80 minus 1 in square bracket, always in square bracket. So these are the dimensions of A, B and C, and now the value of current. So for this we have, as current is d by dt of Q, where the value of Q, if we substitute as AT square plus BT plus C, after distribution we will have A d by dt of T square plus B d by dt of T plus d by dt of C only, C alone constant, so it will give answer 0. dt upon dt will become 1, and this T square is 2T, 2 minus 1. This is from the famous relation d by dx of x to the power n is equal to nx n minus 1. And now this is 2AT plus B, putting the value at t equal to 3 second, current will be 2 into A is 3, T is also 3, and B is 5. So 3, 9 to 18 plus 5, that will give 23 ampere. So this is the final answer for current at t equals to 3 seconds according to the given condition. You can note it down by pausing. So with this we have completed the introduction of our second unit, current electricity, and we have discussed a few questions on the initial topic also. On the basis of that only, this is your one practice paper, short practice paper. You can note it down by pausing it, and after that you may practice these questions. Any doubt related to these questions or any other question, you can ask in comment section also. And this class we are completing at this moment only, and in the next class we will do some higher order questions also, and other higher order topics. So till then, take care, goodbye.